Hello everyone, welcome back to my channel. Today we are going to start circle theorems. But before starting the topic, I want to request you guys please like, share and subscribe my channel and press the bell icon for all the videos so that you can get the notification easily and quickly. So let's start today's topic, circle theorems. As we are going to discuss circles today, before that we are going to take the basic concepts of circles, which is if I draw a circle here, so you can see a circle here and here a center point we are making, and this point is called center of the circle. Okay, this point is called the center of the circle. This is actually equidistant from all the points on the circumference. Second thing is called radius. So again, if I'm drawing a circle here, let's take a circle here like this. So as I said, this is your center of the circle, and if you are drawing a line which goes like this, so this line is denoted with r and which is also called radius of the circle. Okay, and if we are making a line which passes through the center of the circle and joining the two points on the circumference, this line is denoted with d and we call it diameter of the circle. Okay, and next thing is very easy and very interesting. This part, this line, this line, the whole line which we are calling as the circumference, right? See, this line is actually called the circumference of the circle, which is actually an outer boundary of the circle. Outer boundary of a circle. Okay, now we are coming to arc. So I'm drawing a very basic circle, freehand circle, and I'm drawing a center of the circle, and I am making 2 points like this, two radiuses which goes like this. So this part, this whole part is actually called the sector of a circle. So basically it is passing from your center and is made by two radiuses and one arc. Okay, so there are 3 4 things here which we need to understand. Firstly, I'm marking my arc. This is your arc. Okay, arc is almost that point which we are talking about, I mean which we are taking for a sector or for any of the length of the arc or whatever we will do further. So that's a part of it, right? It is a part on the boundary of the circumference, right? It could be a small part, it could be a big part. Suppose if we are taking the sector thing in consideration, sector is the inside part, right? The whole part, which is this one, is your sector. But if we are talking about an arc, so arc is only this part, which I made it with a green marker. Okay, and here it is a small portion, and the rest of the part is quite big, which is here, right? So this is basically called a major one, right? So it is major arc, and this part, the lower one here, is your minor arc. Similarly, if I'm talking about a sector, so this part is quite small, so I can say that this is a minor sector. Okay, and this rest of the part, this part is called major sector. So there are few 4 things here, which is about an arc 2 things and about a sector 2 things, major and minor. Whosoever looks small, that is minor. Whosoever looks big, that is called a major one. Okay. Now let's come to next concept, that is called a chord of a circle. Suppose I'm drawing a circle. This is the center of the circle. Every time I'm showing you the center of the circle, the reason is you should understand that whether it is passing from it or not, right? So there are three things here. So firstly, I'm talking about a chord. Second, I'll talk about a tangent. And third, I'll talk about a secant. Okay. So first thing is chord. As I'm saying chord, so chord is a line which passes like this. It should be inside the circle, first thing. Second thing is that it should join, a straight line should join, a line segment should join the 2 points of a circumference. Okay, joins 2 points of a circumference of the circumference of a circle. All right, this is easy to understand. And there is one more exception thing, or we can say an interesting fact about it, that if you draw a line which goes like this, which passes through the center, that is actually called the longest chord of a circle, right? Longest chord of a circle. I'm marking it with a marker to make sure you guys easily recognize it. Okay, so longest chord of a circle is actually a diameter, right? This is a diameter only. So it is an interesting fact about the diameter. It is actually the longest chord of a circle, right? Next thing is tangent. I am drawing one more circle, and tangent is basically a line. See, here we talked about a line segment. Just differentiate everything here so that you guys can understand that we are talking about a line segment. Line segment has a certain measurement, okay? And in tangent, I am saying a line will pass and cuts the circle or touches the circle at one point. Okay, it is going to pass or touch, not pass actually, basically we can say it touches the circle at one point. Okay, so the exact word we can use here, it will touch the circle, touches the circle at one point. Okay, let's eliminate this thing here. So the example will be like this. One more minute, let me raise it and make it a little more precise one for you. This is the line, right? As it is touching your circle at one point, right? So this is called a tangent. Okay, otherwise there is no exception for a tangent. It will pass, it will touch the circle at one point. Okay, next thing is secant. What is a secant? See, secant is, again, if we draw a circle, this is my center of a circle, and again you will take a line here. Okay, here we also talked about a line, not a line segment. Here we discussed about a line segment. Okay, and if we are talking about a line, and it line can pass through like this, so it is actually becoming your chord and actually exceeding from both the directions, right? So basically a line is passing through a circle. Okay, that's what we can say, and it is cutting the circle at 2 points, right? So this is called a secant. Cuts the circle at 2 point. Right? So this way we can understand it easier, right? Next thing is called a semicircle. So semi you already understand, right? I don't think there is a big misconception about anything regarding the semicircle. Semicircle is basically the exact half of your circle. right? So this is your circle, right? If you draw a line which passes through your center, if you flap it, right? If you flip it in this direction, so it is going to give you a thing which looks like this, a semicircle, right? It will show you the half part of it. So that's a semicircle here, right? All right, let's start with the properties now, or we can say the theorems here. First theorem is basically based on a semicircle only. So that is called angles in a semicircle. Or we can exactly say angle in a semicircle. Just a minute, let me write it properly. Angle in a semicircle. What does that mean exactly? So let's draw a circle. Again, I'll take a circle picture here like this, something like this. Okay, so this is a very precise circle. Now I can let me check if I have a semicircle here. No, we don't have a semicircle in this. So let's understand it. If you have a circle here, this is your diameter, like this. Okay, so I can see I'm marking the center of the circle as O. Okay, and now I'm saying that this is a circle, and as I said, we have to take a semicircle thing here. So I am marking down few lines here. Just understand it. If I am drawing something like this, okay, so as I said already in the question, that angle in a semicircle, right? So angle in a semicircle is a right angle. So this is a very easy and interesting property that every time says that if you mark any line from the diameter, or two lines from the diameter which makes an angle to the circumference that makes a 90-degree to it. Okay, let's name it. So I can write it like this: ABC angle is of 90 degrees, right? If this ABC can be in this way as well, let's take one more circle like this. If you're marking down the same thing again, the diameter, if you're marking it like this, like here, or if you're taking it here, something like that. So all of these angles will be of 90 degrees. Okay, it doesn't depend on the vertex, right? It is depending on that it is in the semicircles, right? So that means if you're drawing a semicircle, this is my center of the circle, and if you're drawing any angle over here which joins the diameters endpoints, that makes a 90-degree to it. That's an easy statement. Okay, let's just take the second property that says radius tangent theorem. Radius tangent theorem says that if you are drawing any circle, this is the center of the circle, and if a tangent is passing through it, this is the point of contact. What is this called? This is called the point of contact. Okay, when a circumference and the tangent touches each other, that point is called point of contact. Okay, when this line is joining this thing and this makes a 90-degree to it, this is called the radius and tangent. You just need to remember the words, right? Radius stands for this thing, this is your radius, right? And tangent, we are talking about this thing, right? So they concludingly making a 90-degree to it. Okay, so if I am going to write the full statement here, so tangent to a circle is perpendicular to the radius at the point of contact. That's how it should be. Okay, let me just take an example, quick example. Before starting the example, please like, share, and subscribe my channel for more such videos and press the bell icon for the coming updates. Let's resume. I'll give you a question. If I'm taking an example like this is a semicircle. Okay, one more thing you need to remember, that if I am not drawing a center here, right? That doesn't make a diameter, right? What I mean is, if I am giving you this as A and C and this point is B, right? If I'm not marking this center, right, if this line is going like this, so you cannot say that this circle is a, I mean, this is a semicircle, you cannot confirm it. Okay, so there should be a precise center mark over here, then only you can say that this is a semicircle, right? If this kind of dot is given, that means it is a semicircle to you. Now you can proceed with the further thing. Okay, so this is given as 35 degrees, this angle is given as x degrees, so we have to find x, right? See, I gave you the proper statements and the brief statements. So always use the brief statements for your solution. Do not write the whole statement. That is not required for the exams, right? You just need to understand the basic lines, right? Basic words. Okay. So as I said, this is a marked thing, that this is the center given to you. I can say that this angle is of 90-degree, right? I can directly write the solution as ABC is going to be a 90-degree, and I'll have to write the reason, because this can be a part of a reasoning thing, right? So you need to write the reason over here. So I can straight away write angle in a semicircle. That's all. No need to write the complete statement. That's it. You can leave it here. Okay, now I know that this is 90, this is 35, this one is 90, this is 35, and this is x. So if I have to find x, I can take this triangle property here, right? So I can write 35 degrees plus 90 degrees plus x degree is equal to 180, and the reason is angle sum property of triangle. I can make a small triangle. You guys also can make a small triangle, or you can write a triangle in words. Okay. Instead of this, you can write triangles. That's also fine. All right. So this is called angle sum property of a triangle, when all the angles inside a triangle sum adds up to give you a 180-degree. Right. So that means x plus this is going to give you 125 degrees. So x degrees coming out to be 180 minus 125, which is going to give you a 55-degree as a solution. That's your answer. You can leave it here. I hope you liked today's lesson, and I'm hoping that you understand it. Let me come up to you guys with more such videos, more such concepts. I'll be taking further more theorems of circle, because these two are not the end of this topic, right? So we'll be making a series of it. because we have different kind of things and the properties which are lying here, and we'll take few more different variety of questions which can be little more complicated according to your exams, right? So till then, god bless you guys, take care. Please like, share, subscribe my channel, and keep me motivated to make more such videos for you people. Take care.